All right, hello. We are going to start the worksheet graphing quadratic functions 1a. The first thing I'm going to say about this worksheet is that there is a problem with question 2. If you look at the table for question 2, and I've already made the correction myself, there are y values there. Those are not the correct y values. I didn't accidentally give you the answer. That's just an artifact of the way I made the worksheet. So before you do anything on this worksheet, please go down to problem 2 and cross out the y values. You are going to be finding your own y values using substitution. All right, so let's go back up to the top. The one that I want to do today is problem 1. And I've said many times during the year, if you've been with me all year, that you should be able to graph anything with a good table. And so that's all I'm asking you to do today. There are only 4 problems, but each problem requires 5 separate substitutions. So I figured that that was enough for one day. Let's go ahead and get started. I'm going to take my equation and I'm going to start by substituting 0. I'm going to get right into it. Y equals 2 times 0 squared minus 8 times 0 plus 3, and I think you can all notice that 2 times 0 squared becomes 0, 8 times 0 also becomes 0, and all I'm left with is a positive 3. So in my table, my first y value would be 3. Not only is my y value 3, but this pair of numbers 0, 3 is the first point I'm going to graph. So where would that be? 0, 3 is going to be on the y-axis, and it's going to be 1, 2, 3 units up. And I'm going to make that dot. I want to make it so I can see it, right? And so you can see it too. And so when you're doing your work, same thing. Don't make the dot so small that you can't see it. Let's continue. I'm going to substitute the next number. Y equals 2, 1 squared minus 8 times 1 plus 3. Well, 1 squared is 1 times 2 is 2. I'm going to do that all at once just to save a little space. Times 2. Negative 8 times 1 is negative 8 plus 3. And then again, this is something you put into your calculator just as it looks. 2 minus 8 is negative 6 plus 3 is negative 3. So I ended up with y equals negative 3. And then again, I have another point now, the point 1, negative 3. I'm going to graph that from the origin. I'm going to go over 1 to the right since it's positive 1, and then I would go down 3. That's going to give me a dot right here. All right, the next number, y equals 2 squared minus 8 times 2 plus 3. 2 squared is 4 times 2 is positive 8. Negative 8 times 2 is negative 16 plus 3. Well, that becomes negative 8 plus 3, which is negative 5. So in my table, I would have negative 5. And then that point 2, negative 5 from the origin means I would go 2 to the right and 5 down. It's going to be right here. All right, getting a little tight with space. I'm going to try to squeeze the rest of the work. Let's go back up to the top. And let's plug in the number 3. I'm going to make a line here so you can see that they're separate. So y equals 2 times 3 squared minus 8 times 3 plus 3. And I'm going to get what? 3 squared is 9, and 9 times 2 is 18, so y equals 18. Negative 8 times 3 is negative 24, and plus 3. 18 minus 24 is negative 6. Negative 6 plus 3 is negative 3. That's my y value here, negative 3. Another point 3, negative 3. from the origin, 1, 2, 3 over, 3 down as well. And then finally, sorry, I'll leave that graph up a little bit longer. See if I get everything on that page. And you can already see the symmetric nature of the graph, how the left side and the right side are going to be the same. You could probably even figure out without substituting what the last point's going to be. But let's go ahead and substitute anyway. I'll have y equals 2 times 4 squared minus 8 times 4 plus 3. 4 squared is 16. 16 times 2 is 32. Negative 8 times 4 is negative 32. Plus 3. The 32's cancel to give me y equals 3. So my last y value is 3. And that means my last point is a point 4, 3. If I count that out from the origin, 1, 2, 3, 4 over, and 3 up, I get something like this. And again, we see this symmetry in the table and the symmetry in the graph. Now, if I did my work correctly, all 3 of the remaining graphs will be set up so that they're symmetric around the center point. We'll learn, I believe, tomorrow how we can choose the values to get a nice looking graph like this. Let's go ahead and finish this off though, because this graph isn't finished. If I want to graph the parabola, I need to draw a curve that goes through all these. And when I say curve, I don't mean a straight line. A parabola has a sharp side, but it is still supposed to be somewhat rounded on the bottom. It's kind of like a root, or like a carrot, which I guess is a kind of a root. That's about what it should look like. And of course it has arrows at both ends. So I want to say, I think that may be the first complete parabola we've drawn in this class. So that's pretty cool. All right, there you go. It is a lot of work, but again, I only gave you 4, and I just did 1 with you, so it shouldn't be too much for you to do on your own. Alrighty, talk to you later.